Ave Coders, and welcome to this masterclass on Python for beginners. So please give this video an emperor's thumbs up, toll the bell and subscribe to the channel, and without further ado we will begin. First of all, I assume you have no Python installed on your machine, so we head to the official Python website and we download the Python. You might have a different version as the time passes, and please make sure you tick the add Python to the path tick box and you click on install now. So it is not a rocket science because it literally takes a couple of minutes to install, and then we need to check the version. For that we type in Python version. Again, mine is 3.8.6, yours might be different. And here we have the installed packages. One of the application is the Python shell, where it works as a REPL, where we can just literally type in something and get the response immediately. But of course we want a proper IDE for this masterclass, so we're going to head to the official PyCharm website where we can download a community version. So we tap on download button and we are heading to the next community version download step. So we don't need all that, and because it's going to be another Windows install, all we need to do is just click next and put ticks in the right boxes. So next, and here I'm going to tick the create desktop shortcut and add launcher to the path. I also want it to be a default opener for the .py files, and then click next and install. So that works pretty quick, and that is it. Of course I want to reboot later. Okay, so we have PyCharm and Python and we're ready to crack on. So the first launch is going to offer the theme light or dark. I'm going to choose the light one, although you might choose the dark one if you prefer to work at nights. So I'm going to continue with the light theme. Alright, so now I'm going to start the new project. And I think I will leave the name as default Python project. It's pretty good for a tutorial. What we're going to do, I'm going to change the location to something like tutorial Python-ish. Let me get something that comes first into my head. Tutorial. Yeah, that should be enough. We click create and it's starting our project, launching the environment, and some tips. And now we are pretty much done. We're ready to begin. We are in main.py and we're going to begin with what primitive data types do we have in Python. So we have ints, as known as the whole numbers, such as 1, 1, 2, 3, and even 0, although this is a disputable one. We also have strings, shortened to str, and we write them in between the quotes, single quotes or double quotes. These are the examples. Even the number written inside the quotes will be treated as a string. The next data type is Boolean, which is true or false, on and off, 1 and 0, and so on. The next one is of course float. These are the numbers with the decimal point, such as 0.1, 6.9, and so you've got the idea. So now that we know that we have them, we can do something with them. So I'll leave them here just for the reference. Unlike in strictly type languages where we have to specify the type of the variable, in Python we can write just the variable, and in most cases Python will be able to assign a type implicitly. So let's say we have a channel variable. Say in Java we would have to write string in front of it, but not in Python. Here we can just leave it as it is, and because of the value assigned to it, Python will understand what kind of a type it is. So to run this code, I will get rid of our references and I'll run it. And I highly recommend you to learn the shortcut keys to run or save or do other stuff. But for now, I'll show you how to run it in the old way. So it has printed out the Ave Coder, the value of the channel variable, which is of a type string. So let's say further down I decided to change the value of channel to hello world and print it out again. And so Python will read the code line by line and will print out hello world and Ave Coder as well. Nevertheless, they are two different values assigned to the same variable in the same program. Now let's say we have variable h, we assigned an integer value of 25 and we decide to print it out, and here we go. Let's observe the behavior of the Boolean type. So I'm going to create a variable called isItTrue, and I will assign a value of true to it. And then I'm going to print the isItTrue as well, and so we can see the result. So Python has assigned the value implicitly. Next is a float. So bool will be of type float 0.5, and I'm going to print it out as well. So I'll run the program now and I'm going to get another value of type float. Alright, so let's move on. You will be surprised, but we already have some knowledge that will allow us to write a simple program in Python. Say we want to ask user for a name, and we can do that. We're going to print what is your name, and then on the next line we're going to create a variable called username, and we're going to assign the value from the user's input. To do that, we are using a function called input, and we print the value of that variable username. So it's prompting us what is your name, and we're going to type v, and it prints out our name. Not really useful, but still. So we can modify it slightly to add some interactivity. Let's say we want to greet the user. Therefore, we put Ave in front of it with single quotes. And now it greets us. However, there is no space between them, but that's not important for now. This was just an example. Let's move on to the operations. As you might remember from the primary school, we have the equal sign, the plus, the minus, the division, the multiplication, and so on and so forth. And as you might have guessed by now, we can use them in Python. Let's say we have a variable called number1, and we assign a value of 2. And we have a number 2, and confusingly enough, we're going to assign a value of 10. So we have two integers, and now we can do some operations with them. So let's say we're going to print out the summation of number 1 and number 2. So number 1 plus number 2, and we're going to print out the result of multiplication as well, and as well as division, and we're going to probably need to reverse them so that we won't get the negative numbers. So number 2 minus number 1, and same with the division, number 2 divide by number 1, and let's run it, and as you can see we get the results. A couple of other operators worth mentioning are the exponent, which is this double star, so this performs exponential calculation on operators. So let's say we want to get number 1 to the power of number 2. Effectively this is going to be 2 to the power of 10, and of course we're going to print the result. This is 1024. So the next operator is called floor division. Effectively what it does, it returns the result of the division without the remainder. So if we'll divide 2 by 10, we'll get a 0 because 10 is bigger than 2. But if we'll swap them around, let's say we divide 10 by 2, we'll get 5. It might not be a very good example because it doesn't have any remainder, and the effective result is the same as if we would use the simple division, but you've got the point. So the next operator is called modulus, and it works the opposite way. It returns only the remainder of the division. So when we divide 10 by 2, we do not get any remainder. But if we'll divide 10 by 3, you see that the result is equal to 1, which is indeed true. So let's put our new knowledge into use, and we're going to write a simple interactive program where we're going to prompt the user to give us the number, and we're going to do an operation with this number or with those numbers. And so we're going to ask for the first number, and instead of assigning a value to the number 1 explicitly, we're going to use the user's input, and we're going to print it once again, this time asking for the second number, and once again the number 2 will be equal to the user's input. And if we'll leave everything as is, we'll run into a problem because Python treats user's input as a string. So effectively we cannot perform mathematical operations with strings other than plus, which is concatenation, but we'll talk about it later. And as you can see, we have a type error, cannot multiply sequence but by non-int of type str. So what we'll need to do, we'll need to convert or cast user's input into a number, because otherwise, as you can see in the output, we had 4 and 7, and Python, because it was treating it as a string, it has concatenated 4 to 7, and we get 4 to 7 as the result. But multiplication with strings, there is no such thing. So as I've said, we'll need to cast the user's input into an integer and perform this operation again. To do that, we're going to just put int in front of the user's input and put user's input as an argument to the int. So the casting will be done when we'll type in the numbers. And as you can see, it has successfully performed all 4 operations without any troubles. So these were the main operators in Python. We can get rid of them and we can move on to the next topic. And this topic will be how to compare the values of the variables or the numbers. So greater than, less than, equals, or not equals, and we can easily illustrate that as 8 is greater than 4. So if we'll ask Python about that, it will return true, because indeed 8 is greater than 4. However, if we'll put it that way, it will return false, because 2 is less than 4. And they can help us later on in the simple decision-making process. So this is the sign of equality, this is a sign of not equality. So a single equals is an assignment, a double equals is the equality. So that way it returns true because 2 is not equal to 4. They are indeed different numbers. So if I'll print out, what shall I get? True. Let's give it a try with less than operator, and this should give us true as well. 4 is greater than 2. This will give us false because 2 is less than 2, and this will give us false as well because 2, as I've said, is not 4. However, we can combine them and we can get greater than or equal, or less than or equal. So we can write them this way. This means 2 is less than or equal to 4, and this will mean 2 is greater or equal to 4, which is false, of course. Okay, so let's give it a try, and we'll use them together with a simple decision-making structures in Python. So we can put something like, if something is greater than something, do this, else do that. Or we can check for multiple conditions with elif, which stands for else if. I'll illustrate what I mean. Let's type a simple program. Let's say we have a number in mind and we want our user to guess it. So we're going to prompt the user to input a number. We type guess my number from 1 to 10. And we'll of course need to cast it to int. So we'll avoid the problems we had in the previous topic, so that we'll make sure what users type in will be definitely a number. And then we can start to construct our condition tree. If my number, this is what user puts in, if it is equal to 5, then we're going to do a certain action. In this case, we're going to print you are damn right. And then we're going to need another branch for those cases where user didn't guess the number correctly. So we're going to type else. This is for all other cases. If the number that user types in is not equal to 5, we print something like you are out. Let's give it a try. I'm going to type in, say, 4, and you're out. Okay, so this is something to begin with, and now we can expand it further. So let's say I want to add some more conditions, such as if my number is greater than 5 or less than 5, I want to inform user that you should try to guess another number which is going to be slightly bigger or slightly smaller. So we're going to modify our program. So I will expand my condition with elif. It stands for else if. And else if, or elif, my number is greater than 5. I'm going to print out another statement which gonna point the user into the right direction. Let's say try less. Else, for any other cases, we're going to say try bigger number. This should work. Let's make it correct. Try lesser number or whatever. Let's try and run it. And this is normally how you build the program. So you start with something really basic and then you expand on the functionality. So we're going to try 5. We're damn right. That's it. We need to run it again. 4, try bigger number. Okay, 4 is less than 5. let's try something bigger than 5. Try lesser number. And 6, try lesser number. Everything seems to be working. However, I don't like to restart the program every time I run it. And we'll address this later, but for now let's move on and we'll add some more stuff to our program, which is another condition, and or not. So we can have multiple conditions in the same statement. For example, I can prompt a user for another number, or let's say that's not going to be the number, that's going to be a string, which is we're trying to guess a number and a color. So let's say my color, and we'll ask user, can you guess my color? And here we're going to say, is it blue, is it red, or is it black? So to make sure we narrow the search to those 3 colors. So now, instead of checking just one condition that the number is equal to 5, we're going to check another condition. So we put and my color is equal to, let's say, blue. And of course we shouldn't forget that blue is a string, therefore it must be placed within the quotes. Now we need to give some tips to the user. Let's say if the number is equal to 5 and the color is equal to blue, we say you're done right. Otherwise, elif, my number is not equal to 5 or my color is equal to blue. So the main difference between and or is that in the case of and, both sides of the equation should be true, and in case of or, one of them can be true, one of them can be false. So I've also corrected that my color not equal to blue. So that should read if either of my conditions is not true, or we guessed incorrectly the color or the number, we will print out pick different number and different color. Otherwise, we say else, print, try something else. So once again, this is just a simple bit of code just to illustrate how the conditions work in Python. So we have and, or, and we can also use not. Not has got the similar effect to the exclamation mark and then equal sign. So the logic is something like, if you are not hungry, don't buy a potato. But in this particular case, we can easily modify our code slightly with not. So let's say the elif condition, we can put not in front of the brackets, and then we can remove the exclamation marks. And still it will essentially mean the same. So now this code reads something like, if my number is equal to 5 and my color is equal to blue, you're damn right. And then if my number is not equal to 5 and the color is not equal to blue, you say pick different number and different color. In any other cases, it says try something else. But this is not the only way we can compose our program with these conditions, if and elif and else. We can also nest one condition into the other. For example, I can say if my number equals to 5, we're going to print you're damn right, and then we can nest another condition which will check on the color. So to do that, I'll copy that line inside of our if statement. I'll get rid of those. And now I can say if my number is equals to 5, and again I can nest another if. So we're reading user's input and we're saving that input into the variable my color, and then I can write if my color is equal to blue. Then we'll print the same story. We're going to print "you're damn right." So I'll just copy it from there. I'll paste it here. And now I can get on with the elif statements. So after the nested if, on the same level, I will type else. So if I'm not getting my color right, I'm saying that number is right, but the color is wrong. So you need to pick another color. And then on the level where we checked the number, I will type elif. So if my number is something else than 5, say greater than 5, and here I will use the conjunction and to connect two conditions together. So basically I'm saying if my number is greater than 5 and less than or equal to 10, I will try to provide a user with a tip on which way to go. So in that case, I'm just saying pick a smaller number. And similarly for the numbers that are less than 5 and greater than 0, I can put another condition, elif. My number is less than 5 and my number is greater than 0. I can say something like try a bigger number. So here we go. Elif, my number is less than 5 and my number is greater than 0. Print pick a bigger number. That way we can make sure that user is heading the right direction. And then of course else, saying in any other case we're gonna just print something like you are out of bounds. For example, if user will guess the number, let's say 15 or something like that, and don't forget to cast the user input into int, because Python by default will treat it as a string. So now our program looks neater and we have some sort of interaction going on. So basically we're guessing the number and we guessing the color. So the guess for the color is nested inside the number guess. So we'll only let you in to guess the color if you have guessed the number. But of course this is something we can improve. We can give sort of tip to what color to pick or how many attempts, perhaps in the same way as we are providing a tip for the number. Or I might leave it as a homework for you because it's not too difficult to implement, and you will see why in a minute. And I should also mention that if you will enroll to some paid course, Python for beginners, this is something that they will teach you and you will pay for this sort of knowledge. So enjoy this thing for free and never pay for the beginners course. All right, let's try to run our program. Prompts us guess my number from 1 to 10. I'll guess 3. Pick a bigger number. Try again. Because unfortunately the program doesn't give us multiple attempts, so we have to restart it every time we guess the number incorrectly. Let's try to guess the number correctly. So it prompts us what color do I have in mind. I'll put black, and now I have to restart the program again. Let's try 5 and say blue. You're damn right, that's the end of our program. So I guess now we can add a little bit more interactivity, and we can make sure that the program at least asks you to guess the color and the number a certain amount of times. So you can use the tips provided by the program correctly. And of course we can do that with a while loop. So while loop runs for as long as the condition stays true. So up here I can put while, and here I can specify the condition. While condition is true, we will do some stuff. But as soon as condition becomes false, we break from the loop. So up here I will declare a variable called loop, and I'll make it equal to false. Therefore, here I can say while loop is not equal to true. So as long as it stays false, we will do some action. And don't forget that we need to re-indent our code to make sure it is inside the while loop. So in here, if we guess the number correctly and we guess the color correctly, then we set loop to true. That way we'll break from the while loop. And logically that means that if we will guess something incorrectly, the loop will stay false. So let's test it. 4, pick a bigger number. 7, pick a smaller number. 5, we guessed it right. The color, black. Incorrect, and we're thrown out to the if condition for the number again. So we have to start from the top. So we guessed everything right, and we are finished. So from the start, there are two things we can correct here. We can make sure we're not thrown into the guess number condition every time we guess the color wrong, or we can also add some attempts. So if I'll declare a variable called count and I'll make the number of attempts equal to 3, I can limit the user to the 3 attempts. So literally I'll apply the same logic as I did with loop. So while loop is not equal to true, I can say something like while count is not equal to some condition, and I can say while count is not equal to 3, but I think it will be much cooler if we'll have count performing sort of a countdown stuff. So if I will put count more than 0, so I'll need to do the or. So if one condition is true or the other, and here I can say that count is equal to itself count minus 1. That will make sure we deducted 1 attempt from the count. And as soon as it will reach 0, so after 3 attempts, the condition that count is greater than 0 will not satisfy anymore, and we will break from the while loop. And I also think that it will be a good idea to add some sort of a countdown for the user to read. So we can say something like pick a smaller number, you have X amount of attempts left. So we have a string, pick a smaller number, you have, then by using pluses we will concatenate integer count, and we'll concatenate another string to that count. And here is a little problem. The thing is, we have 2 strings, and if I'll hover over variable count, it tells me it is actually an integer. And if we'll try to run it as it is, we'll soon find out that Python does not agree with us concatenating string to the integer, and vice versa. So I'll launch the program, and as you can see, we get the error, can only concatenate string to the string. But we already know how to deal with that problem. We can cast count to string. So it will read the value of the variable count and it will cast it to string. So Python, as you can see, treats it as a string. Right, so now we can do infinite amount of attempts until we'll actually guess it right. So it doesn't make any sense. So we need to correct that. Because at the moment the number of attempts decrease only if we guess it right, or in case we'll pick the number bigger than 5 and less than or equal 10. But we have a logical flow in our program. So in here, if we'll change or to and, so if two conditions will be satisfied simultaneously, we can see that it makes a bit more sense now. Because with or, it was looking just for a single condition to satisfy, but now it works as it should. And we can repeat that for a number less than 5 or bigger than and bigger than 0. So now the number of attempts will decrease. So I'll change smaller to bigger. And we also might want to add the similar logic to the else statement. So it will read, you're out of bounds, you have X number of attempts. So let's try 4. Pick a bigger number, you have 2 tries left. Let's try bigger, 6. You have 1, 11, you're out of bounds. So pretty much it works as it should. But now let's concentrate on guessing the color and see if we can improve something there. So for every number I would guess now, I'll put 5 so that I can get into the nested condition, if else. So red, number is right, but pick another color and we are thrown out to the number guessing again. And if we put blue there, we will get an error. So this is something we can definitely improve. So 2 things we need to correct here. We need to make sure we're not thrown back into guessing the number every time we guess the color incorrectly, and we need to make sure we add counts to the color attempts as well. And I think in order to make this lesson a bit more interactive, I offer you this as a homework. Please put in the comments how you're getting on. But meantime, we'll move on to the next topic. And since we've already touched on the while loop, so now we know how it works. And next loop, we're gonna have a look at the for loop. So for loop is specified in Python with the keyword for. Then we declare a variable that will traverse in a certain range. So the range is from 0 to 10. And if now we'll print that variable, you'll see that it prints all numbers from 0 to 9 and excluding 10. So the first parameter inside the brackets is something called the start. So this is the point at which we start. And the second parameter is the stop point. So this is the condition at which we stop. And if I'll put another one, that will mean step. So quite easy to remember, start, stop, step. So we print all numbers from 0 to 100 and we iterate in step equal 4. So instead of 1, 2, 3, we're going to go 0, 4, 8, 12, 16 and so on. So once again, we can use something we know already, which is a count. We'll set up to 0 and we'll use this construction inside the for loop. So say I want this count to be increased by 1 every time we iterate, and say we would want to print this count instead of x, and this will have an interesting effect. If when we've been printing x we went 0, 4, 8, 12, 16 and so on, we'll now go 0, 1, 2, 3, 4, 5 and so on, but we will stop at 25. Because 100 divided by 4 is equal to 25, which is equal to increasing count by 1 every 4 steps. Right, let me reiterate, because for loop is the basic that you should know as good as your own name. So the first position, the second position, and third position are called the start. So this is where we start from. Then stop position. This is where we stop. And the third one is the step. This is how wide is the step in our iteration. You will encounter for loop almost in any program, so please do remember. Right, if we'll put the print statement outside the for loop, let's say we'll do the loop first and then we'll print count. That will print the final number, which is 25. That will mean that the loop has done its work and then put the output of that work into the variable count. Right, if I will remove the step, so I will leave only the start and stop, which is 0 and 100. So now the count will be increased every iteration and the final output will be 100. And if I will remove 0, so I will raise the starting point and leave just 100, so the output will be still 100 because 0 is the default position. If I remove everything, nothing will happen because it expects at least one argument. And if I'll leave 0, so you guess it, we'll get 0. And so this is how for loop works in Python. And we'll now move on to the next topic, which is the way we can store data in Python. And I'm not talking about databases, I'm talking about the data types in Python that are used to store collections of data. And we'll start with a list. So lists are used to store multiple items in a single variable. They are ordered, changeable, and they allow duplicate values. So here I've got a list of cars, say BMW, Mercedes, and number 5. And if we'll print cars, we'll get this result printed. Lists do have indices, and indices start from 0. So BMW will be at index 0, Mercedes at index 1, and number 5 will be at index 2, similar to the for loops. And as you might have guessed, we can use it in our favor. So for example, if we want to print just the Mercedes, we can put the index in brackets, such as 1, and we now printed the Mercedes. Similarly, we can add elements to the list. So if I will now remove number 5 and change it to Opel, say we want to delete number 5, remove it from the list, and instead we want to place there on the index 2 Opel. We can do that with a method called append. So I'm going to type cars, then dot, that will give me access to some operators, and I'll choose append. And inside the brackets, I'll put what exactly I want to append cars with. In our case, this is Opel. So if I'll now print the list, we should see BMW, Mercedes, and Opel. I'll also copy the print statement before the operation so we can see the difference. We can also change the elements inside the list by addressing it by its index. So if we want to change, say, a Mercedes onto some other car manufacturer, we can do something like cars 1 and then equals to, say, Porsche. So list will allow us to do so. It is pretty flexible, so let's do just that. Down below I'll put cars, in fact square brackets, and I need to give an index of an element I want to change. In that case is 1, and I'll just put equals to Porsche. Not sure how you spell Porsche right, but it doesn't matter really. And I'll print our list again. So we should see BMW Mercedes, BMW Mercedes Opel, and BMW Porsche. Fantastic, let's move on. List not only allows us to swap one element to another, but also allows us to change elements that are within some sort of range. So if I will add some more car manufacturers to our list, so that we'll have more space for our experiments, say Porsche, Opel and Volkswagen. And I should also mention that we can address elements inside the list not only from the start, such as 0, 1, 2, 3 and so on, but from the end as well. So if I'll put, say, cars -1, that will print us the last element, so it will count from the end of the list. So -1 should give us Volkswagen. Yes. Similarly, -2 should give us Opel. That works. So that worked as expected. And if we'll put something like an interval, say from 2:4, that will print us the elements from the index 2 and up to the index 4. That will mean Porsche and Opel. Let's try it. Yes. So the next way to store multiple items in a single variable is called a tuple. So the difference you may spot from the start is that the tuple is using the normal brackets, and also you can't change the elements inside. So now we can see that cars is tuple. Now I'm changing it back to the square brackets. Now it is a list. But we're gonna experiment with tuple. Let's print it out for start. So as you can see, 5 elements still present. And similar to lists, we can address an element by its index. So Mercedes is at index 1. And first element counting from the end is still a Volkswagen. So -1 for the first element from the end. Also the range from 2 to 5, we can see Porsche, Opel and Volkswagen. And we're also allowed to add duplicates to our tuple. Let's see, BMW and BMW. Let's try to print it out. As you can see, we have 2 BMWs inside our tuple, and we have no warnings or errors, which would not be the case for set, for example. So, but there is a slight difference. So if I'll change our tuple back to list and say something like I want to change the first element, which is BMW, I want to swap it for a Mini Cooper. So cars 0 Mini Cooper, it will allow me to do so. So the first element becomes a Mini Cooper. If I'll change it to a tuple, and I'll try to do it now, so change Mini Cooper back to BMW, it will now not allow us to do so because tuple does not support item assignment. And of course, in many situations, we can use this feature of tuple to our own advantage. Let's move on, and the next data type used in Python to store collections of data is called set. Set is unordered and unindexed, and again it is used to store multiple items in a single variable. And set uses curly braces in its syntaxes. And now I print the set, and as you can see, the order is not preserved. So I can get rid of this indices. And if I'll try to assign something by index, I'll get an error. And in that case, all we need to do is use the loop. For example, we can use the for loop, the classical for loop for this task. So I'll type for car in cars. So car is going to be our variable that we're going to use to traverse inside that loop. So in this case, we're going to loop element wise inside the cars set. And if I'll print it now, you can see that it has just printed our set 5 times. And as you can see, every time I run the loop, the order of the elements was different. But if I'll change cars to car to actually the name of the variable that we use to traverse, this time we're gonna get each element of this set rather than the whole set. So this is one of the downsides of set, but on a positive side, unlike in the tuple, we can add elements to our set. And it even provides a special method in order to do that. It's called add. So we can type cars.add, and inside the brackets, we're going to specify the element we want to add. Let's print our set again. And as you can see, now we have 6 elements, but they are all in random order. And since the order doesn't matter, we can actually add several elements with one method. So this method is called update, and inside the normal brackets we have to use the square brackets, and inside those square brackets we can comma separate the elements we want to add to our set. So in this case I'm adding Citroën, Renault, all those French cars. And this should give us a set of 9 elements, 9 cars effectively. And if we'd like to find out the number of elements in our set, effectively this is the length of our set. We can actually use the specified method, special method to do that. So I'm gonna go with cars, and I'm gonna put it inside the brackets for the len method. Len is a short for length, so prints the 9. So we have 9 elements in our set indeed. And in case we want to delete an element or elements, we can use a method called remove, but since we cannot address an element by its index, we have to specify it by the key. So if we delete Citroën, we get 8 elements in our set. And if we'll remove another one, say Ford, we can get an error because there is no such thing as Ford in our set. But if we don't like to see this runtime errors, we could actually construct some condition. Let's say if Ford is present in our set, then we will delete it. Or if something is present in our set, we'll delete it. Otherwise, we'll throw an exception. And we'll talk about the exceptions later in this course. So we could either do it like that. So if Ford in cars is equal to true, we'll remove Ford from the cars set. Otherwise, so we type else, we actually print a message. We don't have this car. And if say we want to have a more generic condition, we can replace the Ford with a variable, say x, and now we could just use the same condition, but we can just swap the values for the variable. So we tried with Renault. So Renault is in the set and is now removed. But if we'll try something else, say Lada, then we'll get a message, we don't have this car. But I've actually forgot the print method, so I'll add it now. So we're going to print that message and I'll rerun the program. And as you can see, we have a message, we don't have this car, and the rest of our list. And if I'll remove the last print statement, we just get the message. But I guess the Python programmers were eventually fed up with writing this if-else statements, and they came up with a method that is doing the same thing as remove, but does not cause a runtime error. And as a homework, I'd like you to go and see the set documentation and put in the comments what this method is. But we'll move on. And the next type of collection that I'd like to talk about is called the dictionary. So dictionaries are used to store data values in key value pairs, and it is ordered and changeable and does not allow duplicates. It uses curly braces as well as set, but this time we need to specify the key value pairs. So if I'll type BMW, I'll open and close curly braces, and inside I'll put something like make for the car make, and I'll specify BMW as the value. So make as a key and BMW is the value. Then goes the model, let's say something like i8, the electric hybrid, and the color is gonna be white. And if I'll print the BMW, so I type print and I pass BMW as an argument, and you can see that it has printed all key value pairs separated by the comma. And we can also change the values of our keys and values. And in order to do so, we just specify the key, so the string, let's say color. So I'm using the square brackets, and inside I put color, and I assign a new color, say black. And if I'll print the BMW again, you can see that color has a new value, which is string black. And similar to sets, we can find out the length of our dictionary by using the length method and passing BMW as a parameter. And it prints out that we got 3 key value pairs in our dictionary BMW. We can also iterate through our dictionary. Let's say we want to print all the keys. So we're going to use the for loop for X in BMW. We're going to print X. So without any additions, it's just going to print the keys. So we have make, model, color, and this is the 3 is from other print. I'll delete it. But don't forget that variable we use for iterations, it needs to be inside the square brackets. And if we want to loop through the dictionary and print the values, we can use the method called values. So I type in bmw.values, and inside the print statement I just print X, and this should be enough. No, it's not. What have I forgot? So values as a method should be ending with brackets. Okay, so these are the values of our keys. If we want to do both keys and values, we can specify 2 variables, say X and Y, and instead of values, we're going to use the items method. And we're going to print both X and Y, and this is showing us the keys as well as their respective values. But what if we want to get a specific value rather than printing all keys or all values or both? So in order to do that, we can do a method called get. So I'm assigning the value of bmw.get to X, and then I print X, and I want to get a value of the key make, and this is indeed the BMW. We can also easily add key value pairs to our dictionary, so I'll show it in a second. I'll just get rid of all that. And if I'll write BMW, and inside the square brackets I'll specify the key and the value outside the square brackets. So let's say year is 2020, And if I'm going to print our dictionary now, we can see that it was appended with another key value pair, which is year 2020. And if you want to remove a specific key and its respective value, we can use a method called pop. So I type BMW pop, then I put just the key name, year, and I print the BMW before and after. So as you can see, in the first case we have year, and in the second one we don't. Let me add the year again for the next experiment. So let's make sure, yes, it came back. And I'm going to show you another method which is called pop item. So from Python 3.7, it removes the last added key value pair. So we should get the same result as if we would remove it with the key. But let me first check that I'm running the right version. So it's 3.8.6, that should be enough. So let's print the BMW, and pretty much it is the same result but without extra writing. And if we want to copy our dictionary, we can use a method called copy. Let's say we decided to add another dictionary called Mercedes, and I'm going to assign, so I'm going to make it a copy of BMW, and then I'm going to change the key value pairs. So essentially the values, I'm going to leave keys as they are. So if I'll print the Mercedes now, it's going to be a complete replica of BMW dictionary. But before I'll do that, I'll show you another method which is called clear. So that essentially will gonna clear all key value pairs from our dictionary. So if I'm gonna type Mercedes clear, of course nothing happens because we need another print statement. So I'm gonna copy it right after the Mercedes clear method, and as you can see, we have an empty dictionary. There is another more straightforward method to copy dictionaries, which is just assigning a dict as a dictionary to the variable. Let's say we want dictionary called Porsche, and we're going to make it equal to, we're going to assign the dictionary Mercedes, and it's going to produce another empty dictionary, but this time without a method called copy. And we can also use the similar approach to populate our dictionary. And we'll start with Mercedes. So I'm going to type Mercedes, then I'll assign the dictionary dict, and inside the brackets I'm going to be typing the key value pairs. So make equals to Mercedes, then model is going to be equal to, let's say, S-Class, Saloon, and should make it proper string. And color is going to be equal to white, or rather black. And if I'll print our new version of Mercedes dictionary, we're going to see, but it's not empty anymore. It is rather a normal dictionary with make, model, and color. Nothing restricts me from adding more key value pairs, but I just want to make it consistent. So I can do Porsche, and inside the square brackets I can put make Porsche, and this is another syntactical way to populate dictionary, but with a single, this time with a single key value pair. So make Porsche, and I can do the same for the model and color, but I don't want to. I'll rather delete this Porsche. So I'm using the method del. It's that easy. and if I'll try to print Porsche now, we're going to get runtime error. It's not such dictionary. And we can also store multiple dictionaries inside other dictionaries. So in this case, I have a dictionary called cars, and it consists of 3 dictionaries: BMW, Mercedes and Porsche. So in this case, BMW, Mercedes and Porsche are the keys, and I can copy what used to be a key value pair inside the BMW dictionary itself, so I can make it as the value for BMW. And I'll do the same for Mercedes and Porsche. So a lot of copy paste is going on. So I'll make the structure consistent. So make Mercedes, the model will be S-Class Saloon, and let's say the color, we'll leave the color as white, and Porsche, of course, it's going to be make Porsche, then the model Carrera GT, and we're going to make it black. So now we have a dictionary cars that consists of 3 dictionaries: BMW, Mercedes and Porsche. And of course, what we're going to do now, we're going to try and print it to see what it looks like. So I'll make sure all the brackets are nice and line up. That's better. And now I can loop through our dictionary the same way as we did through the single dictionary. And if I'll print it, so it's going to print 3 keys: BMW, Mercedes and Porsche. And again, I can print the key value pairs by declaring 2 variables, x and y, and we'll use the method called items, which we already know. And if I'll print our x and y now, we'll get the dictionary of dictionaries. Let's move on. The next topic is the string. Let me clear the screen. By the way, you can play with it, try other methods or adding and removing, but we'll talk about strings now. So I'll declare my string and I'll assign the value Ave Coder, and the simple operation print my string, and we should get an Ave Coder printed to our screen. Indeed, and as you can see, we have spaces before and in the beginning and in the end of our string. I can slice the portion of my string from the index 3 to up to the index 7. Let's see. So that prints us E, comma, space and capital C. So elements inside the string are counted from 0. So if I'll enlarge the range to 10, we'll see that we're going to have more letters printed. And similar, if I'll do the negative index, so I'll count from the end of the string. So we'll see that I only have 3 letters, O, D, E, which is the slice from the 5th position up to the 2nd position, but counting from the end of the string. By positions, I of course mean indices. And if we want to find out how many elements we are getting inside of our range, we can use the len method, and we're going to put the myString slice inside the method. So indeed, we're getting 3 elements. There are also 2 interesting methods, which are lower and upper, which is going to convert our string and all elements. Say we have the uppercase letter or uppercase letters, and by using the lower we'll convert everything into lowercase letters, and on the contrary, if I'll put upper, now everything is caps. If we want to swap values of any of the elements, we're going to use the method replace. So first argument is which symbol we want to replace, and the second argument is the value of the replacement. So as you can see, we have now the same string Ave Coder, but coder is written with the K, and similar. And if we want to split our string into two, we'll specify the criterion by which we'll split, say a comma, and we'll use the method split. And now you will see that there are two strings, Ave and coder, and comma is no longer a part of a string. And if you'll recall, our string is prepended and appended with spaces. So to get rid of them, we can use the method strip. And this is useful in passing the login and password fields values in, say, authentication form. We'll make sure user does not put any extra spaces. All right, so let's move on. We'll specify another string called Ave, and we can check whether my string contains our Ave string in it. To do that, I'm going to use Ave in my string, and if I'll print Ave now, we'll get the Boolean value, which is true, because of course Ave Coder has Ave and coder, and if I'll reverse the condition, say not, then I'll get false. And now 2 words about the placeholders. So these are essentially the places basically where you can put some other values later on. Let's say we have a variable called name that consists of 1 character v, and we have my new string, which is Ave, and then I'm using the curly braces with the exclamation mark. And if I'll print something like my new string and use the method format, and then inside the format I'm going to put my new variable name, so the Python will automatically replace that curly brace with the value of the name variable. And we can also change the hard-coded value of our variable name onto something that, say, a user can type in. To do that, we're going to type input, and now it's going to read the input, and it's going to replace the placeholder in the my new string. Let's say Julius, and it's going to type Ave Julius. So it has replaced those curly braces with our input. And now that we know how the user input works with the placeholders, we can create a popular kids game called the Mad Libs. So let me delete all that, and we can begin to write our Mad Libs game. So let's say we'll have a series of variables. First one is going to be called the direction 1, and its value going to be hard-coded to turn right, and the second variable is going to be direction 2, and its value going to be turn left. You can see where this is going. And direction 3, it's going to be turn left, then right. So imagine someone asks you how to get somewhere, and now I'm going to declare a variable called path to the shop. So someone's trying to get to the shop and is asking you for the directions. So you say first placeholder, then there's another placeholder there, and finally the third placeholder. And I will finalize this with, and you will get there. So now that we've got our phrase ready, we can start to substitute the placeholders with our variables. So I'll take our phrase path to shop and I'll use the format, and inside the brackets I'm going to list the variables, and now we get the final phrase: first turn right, then turn left, and finally turn left then right, and you'll get there. And again, if I'll change the order by which I'm passing those variables into the format method, this will affect the final phrase because it will sort of shuffle them around. But instead of tediously changing the order of these variables, I can do something neat. I can actually amend the placeholders we have in the original phrase by adding indices. So let's say our first placeholder will have index 1, then second is 1, and is 2, and say the final is 0 again. That way we'll shuffle around our variables. So instead of what we had before, now we have first turn right, this is the direction 1, then turn left, then right, this is direction 3, and again turn right, this is again direction 1. But it's all still hard coded. What if we want to make this game a little bit more interactive? So let's do a new scenario. Say we have a price which is 99, an integer, and we have a full price which is a string that says the full price is, and then the placeholder, and then we have the colon and .2f. That means that when eventually we're going to print our full price by using the method print and then method format, we're going to pass price as an argument, we'll get 99.00. So this 2f means how many digits we'll get after the dot. So if I'll change it to 3f, we're going to get 99.000. So this was another scenario, another way how we can use the format. And now imagine we will declare a new string, let's say my order, and it's going to be equal to the string I will have, then placeholder, and here I'm passing the key. So the key main as main. So imagine this is something like you ordering your food in a restaurant. So pretty much the same thing like in the first scenario with directions, but this time instead of indices we are using the actual names of the variables, the actual keys. And if I'll print my order right now, I'll use my order format and I'll pass value for the key main as chicken, and the side is going to be equal to, let's say, corn. So if I'll print it now, I'll get something like, I'll have chicken as a main and corn as a side, which is neat. That way I can change the values of the keys. Say main is now equal to fish and side is equal to chips, and now I'll get fish and chips. I'll have fish as main and chips as a side. Let's move on, and now I want to talk about something that's called the escape characters. So let's consider the following example. Let's say I want to print a string which I enclose in double quotes. The string is why mighty flossers always win, or always lose rather, to aspire bakers. This is my question about some sport teams all the time. But what if I require those names, mighty flossers and aspire bakers, to be inside double quotes? So I want to quote the names of the teams. Now the Python will think that there are several strings in my print statement. The string y, the string always lose to and the string all the time. So it has excluded the multiflosses. So escape characters, this is a trick, will help us to tell the Python that this is not an actual double quote. You don't need to act on it. This is just something from the text. All right, let's move on. There are two more string methods I want to cover. First one is called find and the other one is called count. So let's imagine we have a string called myString and it contains Ave Coder. And so let's say I want to find out whether myString contains a specific symbol, and I'm using method find, and here inside the quotes I'm passing the symbol. So in my case this is uppercase letter C, and I'm going to print what it returns. It should return the index. So as you can see, the index 4, this is right because everything counts from 0. And Ava is 0, then V is 1, E is 2, then space, and C is 4. If I'll change it to E, I'll get the index 2, which is again precisely where the letter E is. But if we'll try to allocate, say, something that does not exist in text, we're not getting the error, rather we're getting a -1. Right, so the next method we're going to look at is called count. So it's going to count how many times does letter Z is repeated in my string, which is none, so 0. And I'll change it to E. And indeed, we have 2 letters E in our string, Ave Coder. And if I'll change it to something like capital C or other lowercase c, it will return 0 because the method itself is case sensitive. But we can do a little dirty hack. We can use the method we know already, which is called upper. So we can literally move all characters into the uppercase. So I'm going to type something like myString.upper, and I'll do the same for the character C. So I'll do C.upper, and it should return 1. Yes. Alright, so we're done with the introduction into strings, so let's talk about the functions. So functions in Python are defined with the keyword def, and it is followed by the name of the function. Let's say I want to call my function Barry says hello, then brackets and colon. Then it is very important to keep everything indented. And let's say it's a simple function that prints something like woof woof. So let's say Barry is a dog. So now I can call this function by its name, say Barry says hello, and it will return what it's supposed to return, which in our case is woof woof. So if I'll launch it now, we see we get woof woof. And this is of course a very simple example. We can do all sorts of stuff inside of our functions. So for the next example, I'm going to create a new function that will multiply the numbers. So we're going to supply this function with some numbers as an input, and it will produce their multiplication as an output. So let's say def multiplier with a parameter x, and let's say it will return the result, which is equals to x times 2, and will return the result. And now if I'll specify the value for the variable x, so I'll print multiplier, this is the name of the function, and I specify the argument, which is 2. We need to print it. So we should get the return, the inner logic of this function, which is multiplication by 2. And this is something that's called parameterized function. So we can change the values to 3 and 4, And as you can see, this is a 4, 6, and 8 respectively. We can also input several arguments at the same time. Let's say I'll get rid of that, and instead of just x, I'll put x and y, and this time we'll return the multiplication of x and y. So in this case, I need to pass 2 arguments into my function, and I should get 10, which is 2 multiplied by 5. Bear in mind that the number of arguments we pass to our function call should be equal to the number of argument it expects. So if I'll just put 2, I'll get the runtime error. It expects another argument for y. Functions are the cornerstones of any programming language, and you'll meet them obviously a lot in Python. And let's have a look at another example. So this time, let's say Barry is not a dog, but let's say Barry is a parrot. And now we can pass something that's called arbitrary arguments. So let's say we don't know how many arguments will be passed into our function. So we add an asterisk before the parameter name in the function, and this way the function will receive a tuple of arguments and can access the each argument accordingly. So we type asterisk and then my words, and now I can type as many words as I want. So we'll print my words, and inside the function call I can put for start just hello, so it prints hello. And let's say I want it to return several strings. For example, I want our parrot function to say hello Barry. I need to split them. So at the moment this is just a single string, but if I'll comma separate several strings, let's say hello Barry, so these are going to be separate arguments, we'll still return those arguments despite it's more than one. It will not throw a runtime error that there are too many arguments. So this is the power of arbitrary arguments. And so we can actually expand a little bit on that, and instead of just the arguments, we can pass the key value pairs. So inside my function we'll specify a string, say good, and then concatenate it with a variable of whatever value we're going to pass into that function. So I'm going to change it to say breakfast time, and in here breakfast time as well, and I'll add a couple of more. I'll just leave it for breakfast time for the moment. So I'm going to pass into the function that breakfast time is equal to morning. I'll delete that cheeky comma and we can launch it. And as you can see, it was successfully concatenated. It now says good morning. So let's add some more arguments to the function call. This time we say nothing happens, and this will be equal to the afternoon. And finally we can say dinner time, and it's going to be equal to the evening. But now we need to add extra parameters to our function. Let's say we have breakfast time, we have nothing happens time, and we have dinner time. And now by changing the parameter inside of our print method, we can display various time. Let's say good evening, that's for the dinner time. And you can play with it in your own time. So let's move on. I'll get rid of all that. But what if we want to specify a function that does nothing? Let's say we want to implement this function later, but we don't want to forget about this. So we're going to introduce something that's called the pass function. So we can just put the keyword pass into the function's body and nothing happens. Before we'll move on to the different topic, I'd like you to open the documentation and have a look what the args are, and put this in the comment below the video. But our next topic is the work with the files, how we can use Python to read the files, delete parts of it, or append it with some other text. So we have this classic lorem ipsum, which is basically a text placeholder, and we're going to be experimenting with it. But before we'll do anything with the text file, we need to make sure it is opened for Python. So to do that, we'll declare a variable file, and then we'll use the method open, where we specify the name of the file. Just make sure it is in the same directory as your main.py. Otherwise you need to specify the root, specify the path to the file, and then we need to specify what do we open this file for. So there are several parameters, such as R for read, A for append, W for write. And if we want to create a file from scratch, if it doesn't exist yet, we can use the parameter X. X stands for, surprisingly, create. And we can pass one of those parameters into our open method. In our case, we want to read the file. So we're going to pass R inside the quotes. And now we can print the file. Let's see what's going to happen. And we got an error. And in this particular case, it is telling me that no such file exists. So the Python cannot find this file. So we need to specify the path. I'm just copying my path to that file, and it doesn't work. So let's have a look. Unicode escape codec can't decode bytes in position 2, 3. So this is something to do with the path to the file. So because I'm using Windows, I have backslashes, and we need to escape them, as we did with quotes in the escape characters part of the course. So now it tells us that the file is indeed found and opened, but it doesn't work as intuitively as we thought. So we need to add a method to the file variable. So this is what we want to do with the file, and we want to read it. So that is the file. So it displays the content of the whole file. But if we want to, say, read just one line, say the first line, so we're going to pass the readLine method. That prints the first line. And if, for example, we want to read just first a couple of letters of the first line, say lorem ipsum, so we're passing the argument 5, and that prints the first 5 letters, so essentially the first word. And we can also use for loops to iterate through the file content, and in our case that's going to be a simple for loop for x in file, and we're going to print x. So let's give it a go, and as you can see, it has printed all lines of the file. When we're finished with the file, we need to close it, because otherwise it will remain open and will continue to consume resources. So that case is not a good thing. So let's have a look how we can actually modify the file. So in case we want to append something to the file, we need to change the parameter R to A, and now we can use method write, and we can pass what do we actually want to append this file with. In my case, this is going to be a simple phrase. This is written in Latin, and we close the file after the operation. And let's read the file after we appended it with the phrase. And we do print, read, and now you can see, if I'll scroll, you can see that the file is written in Latin, was added to the very end of the file. By the way, those parameters we're changing correctly are called the mode. So if I'll change my mode from append to write, and I'll leave everything else the same, we can see that now the text is gone and the only thing that is left is our line. So the text was overridden by what we've put as the argument. And by the way, nevertheless, we have a separate mode for creating files, which is X. We can also create files with W, with write mode, by just specifying a name of the file that doesn't exist. So in our case, this is Ave.txt, and we'll try to read it. We'll assign it to a new variable. It says not readable, and of course that is the case because we didn't change the mode. So we need to repeat the whole process with reading file. So I'll just change the name of the file, Ave. And now it should be working fine. It has returned the content of the file. So I need to modify the variable. And this time returns nothing. So the new file was created, but it is completely empty. Alright, for now I will comment out our previous exercises. So we'll be just left with file 2. So I'll comment all that out. And we can continue our experiments on file 2. So our file is currently empty. Let's correct that. We'll use method write and we'll put file number 2. And now as we read file 2, it comes back with file number 2 string. Alright, so what if we want to delete the file? In that case, we'll be working directly with operating system, and for that we need a separate library called OS. So I'm going to import it, and in here I'm going to specify that I want to delete file 2. So in order to do that, I'm going to call OS and .remove. And in here I need to specify the full path to the file I want to remove, which in this case is going to be ave.txt. So please don't mix it up with the name of the variable, file 2. And I'm gonna get rid of it and copy it further down below so we can actually check that the file does not exist, no such file or directory. So file was successfully deleted. And importing libraries is the common practice because there is no point writing something from scratch. We can just import the library that was already implemented and use the methods and functions inside that library. So you can have a look at the list of Python standard libraries, and there are also very famous ones like pandas or NumPy, which we'll talk about in a separate video. But I should say that there are tons, literally tons of libraries written for Python. But we can also do something similar ourselves. So for example, we can create a separate module and implement some function in it, and then import it into our main.py and use that function inside of our main file. So let's say we have hello module.py and here we define a function, say hello. That function takes one parameter, which is name, and let's say it just prints hello plus name. So essentially it's going to print the greeting. Right, we save it, and then we come back to the main.py, and in here we can import hello module, and then we can call the function of hello module, say hello, and here we are passing the argument. Let's say we wanted to say hello v, and if we'll launch it now, it returns hello v. So this is pretty much the explanation of how those imports work. And if we don't want to use the long name, we can actually do an alias. So let's say import hello module as hm, and now we can call hm instead of hello module, but the functionality will stay the same. Right, so this was a brief explanation of how imports work. Next topic, we're going to talk about the scope. I should also mention that we're going to have a separate lecture on object-oriented Python, but here we'll just merely scratch the surface, but still we need to understand how it works. So I'm defining the function called funky, and inside the function I'm doing assignment. I'm assigning 10 to a variable x, and then I print the x, and I'm calling the funky, and so it returns 10, which is as expected. And as you have noticed by far, Python is an indented language, so indentations, they do play a massive role. So if we'll define another function inside of our function, let's say this is going to be inner funky, we'll move our print method inside the inner funky, and outside of inner funky we'll call it. It still returns 10, so the call to inner funky is still happening inside of the function funky, and that's why it returns the value of x, which is defined at the same level as the call to inner funky. But now let's consider a different scenario. We have the assignment outside the function, so inside the function we'll get rid of that inner function, and of course we need to get rid of the call to that function, and we'll leave print inside and outside of that function. And as you can see, it prints 10. There's no problem with getting that value of x from within the function and from outside the function, of course. But what if I will declare another variable x, but this time inside the function? So inside def funky, I'll say x equals 5. So what those print statements going to print now? So because the new assignment is treated as local to the first print statement, it's going to print the value of 5, and of course the print statement outside of function will operate on the same level with the x outside the function, and it's going to print 10. But if we would want our local x to be accessed from within the function and from outside the function, so we can use the keyword global, and we can declare it as a global variable, which you should be careful, because in some cases it may have unpredictable repercussions. So we defined x as global, and now print statement from outside the function treats the x local variable inside the function as the global variable, so it forgets the value of x equals 10, and now x equals 5 is treated as if it was written outside the function. So both print statements print the latest value of x from within the funky. Alright, so that's all on this topic. As I've said, they're going to be a separate lecture on object-oriented Python, and we move on to the last topic of today's lecture, which is exceptions. So we've seen all those red runtime errors when things didn't go as we planned. And of course, the runtime error stops the program execution. And is there a way to avoid that? Yes, there is. This is the right topic, which is exceptions. So what they allow us to do is, in a way, to predict the misbehavior of our program and sort of instill a precaution into our program. So with the keyword try, we specify what we expect our program to do. So this is the path when everything goes well. So in this case, we have a variable phone number, which reads the user's input. So we basically read the user's input and we print what was typed in. So again, a try is wrapping up the part of the program where we think everything will go well. So we'll take the input and it will print your phone number is and the value of the variable phone number. But in case something will go wrong, we need a precaution, the keyword except. So this is the part where we specify what to do in case the code in our try part didn't work correctly. So just in case something went wrong in the try, we will print something went wrong. Please try again. So it's a pretty similar logic to the if-else statement. So if everything is okay, we'll do this part of code, else we do that part of code. It is actually so lookalike that we literally can use the else keyword. And for example, here we'll specify everything works okay. So our try block has completed and successfully printed out the phone number, and we'll append it with a statement that it's working okay. So we're going to type in some fixtures phone number, and as you can see, here's your phone number, it's working okay. But if we want some piece of code to be executed despite of success of try, or in case it throws an exception, so a piece of code that will be executed regardless of what happens with the actual code, we can use the keyword finally. So in this case, we'll print, I'll print it, you like it or not. So once again, this is one of those whatever happens moments. So if we'll launch it again, we can see that we need to type in the phone number, we do, and it's working okay. I'll print it, you like it or not. But let's try to diverge our program into a different scenario where it throws an exception. So as you remember, user's input is string by default, so numbers or letters doesn't matter. So in this case, we're going to cast it into int, so to make sure the input is actually a bunch of numbers. So we'll type in numbers with letters, and so the exception been thrown. Something went wrong, please try again. And then the finally statement is printed regardless of the outcome. The finally bit is very useful in case, for example, you have a file that needs to be closed regardless of what is going on with the writing or reading the file. Otherwise it will consume resources. So this was the first scenario on how we can throw or raise exceptions. But the second scenario, we can literally raise them in various parts of the code. So imagine we have a variable this time called x that reads user's input, and we're going to cast the input to integer straight away. And then we have a series of conditions. For example, if x is less than 0, we're gonna raise an exception. So rather than just printing something like the x is negative, enter some bigger value, we can do pretty much the same with the keyword raise and then exception, and inside the brackets we put something like x can't be less than 0. So it is pretty much the similar construction as if we would just have a print statement, but this time it is done via the exception mechanism. Another scenario is when, for example, x is not an integer. Rather than writing try, except, and all that, we can just write if not the type is int. So if it's not of a type integer, we'll raise the exception of a special type. So exception is the generic word, but exceptions do have types. For example, we have a separate type error just for this scenario. All right, congratulations, you made it to the end. There will be more lectures in this series, for example on object-oriented Python, on libraries such as NumPy pandas, and other interesting stuff on the way to becoming a Python developer or machine learning and data science specialist. Please give this video an Emperor's thumbs up, toll the bell and subscribe. That was V. See you in the next lesson. Thank you and goodbye.